Okay, proving circle area formula using definite integrals. First, semicircle equation with radius a. So, uh, square root of a squared minus x squared. Yeah. So now we will be trying to find a, and then multiply it by 4 to get the entire circle area with radius a. So area will be equal, it's this piece right here, the, so that's equal to from 0 to a of square root of a squared minus x squared dx. Now let's solve it. And then after that we will multiply it by 4 to get the entire circle area. Well, to go from 0 to a of square root of a squared minus x squared dx. Let's use a trigonometric substitution. Let x be equal to a sine theta. So dx will be equal to a cos theta dx. What is dx? Well, dx will be equal to the derivative of x with a sine theta with respect to theta. So then we can change the limits of integration in trigonometric substitution. Just find theta and plug it and plug the limits to theta. That's the inverse sine of x over a. So theta. So from 0 to a, well, this converts to integral from theta of 0 to theta of a. Now so apply it to a first. So a over a is 1, so inverse sine of 1 is pi by 2, and then the theta of 0 is the same. So 0 over a is 0, hence inverse sine of 0 is 0. Okay, so so integral from 0 to pi by 2. So let can factor the insides of the square root, and then so okay, yeah, square root of 1 minus sine squared theta, Now why the squared? Because dx will be a cos theta, so constant multiple. We move a to the back, or I meant outside of the integral, and then a times a is a squared. So yeah. Now d theta. Wait, no, I meant cos theta d theta. Yeah. Straight apple. Okay. So now trig identity. 1 minus sine squared theta is equal to cosine squared theta. Now, square root of x squared is equal to absolute value of x, and that is true for all values of x that are real. Squared integral from 0 to pi by 2 of cos theta times absolute value of cos theta d theta. Now that leads us to the question: how can we solve this integral? Well, here's the fact. So absolute value of cos theta is equal to cos theta theta for theta that is between negative pi by 2 and pi by 2, positive pi by 2. Now it's also true for other theta values, for example, like an angle that is it's true for all values of it's true for all theta or angles that are between these and cannot reach these, but only basically it's for a theta or angle that cannot come here, and all that can be here. Okay, and so that's, and the integral is from 0 to pi by 2. So L plus a squared integral from 0 to pi by 2 0. So that becomes cos squared theta d theta. Now here's that another trig identity. Cos squared theta is equal to cosine of 2 theta plus 1 all over 2. So that becomes so alpha squared, and then a constant multiple rule 1 half integral from 0 to pi by 2 of cos 2 theta plus 1 d theta. Now least brackets, or I meant square brackets, because whatever. So that's squared number 2 to go from 0 to pi by 2 cos 2 theta d theta plus integral from 0 to pi by 2 d theta, which is just pi over 2. Now what is this integral right here? Easy, just use duration, time and use substitution, so that u be equal to 2 theta, so du is equal to 2 d theta, so d theta is equal to uh, you know what, we'll just oops, wait, let me just move this. I'll just kind of rotate it. Okay, so a squared 1 half. Okay, so now this integral, well, that's 0. That's equal to multiply those fractions together to get pi over 4. So pi over 4 a squared. Now wait, there was a mistake, except it wasn't really a mistake. When I factored the square root of, I got the square root of, using the rule, square root of ab is equal to square root of a multiplied by square root of b. Now so it became square root of a squared multiplied by square root of 1 minus sine squared theta, and then move the square root of a squared to outside of the integral, and then turn it into just normal a instead of turn it into absolute value of a, because I'm doing this for a that is bigger than 0. Why? because in the real world length cannot be negative. Well, in math maybe, but in the real world, the actual real world, length is not negative. It cannot be negative. It's impossible. Right. So we got a equal pi by 4 a squared. So 4a, that's the entire circle's area with radius a. So that's 4 pi over 4 a squared. Now this cancels out and becomes pi a squared. The things in math, the radius is often used with the variable r. I mean r is often used as the variable for radius. So 4a is equal to 4a radius will be r equal to pi r squared. Okay. Now now there is now another proof. So oval area proof. Well, actually I don't really know the oval area formula, but I will try to find it using definite integrals. So semi-oval top semi-oval equation. So I'll just directly say it. Okay. So with a b. Okay. Now the entire area of this oval will be equal to 4 multiplied by this area, which will be equal to area represent this time it represents the entire area of the circle. So a over 4 is equal to go from 0 to a of b over a. Now we put it outside the integral. Square root of a squared minus x squared dx. Oh, I already have done this before. This integral. Oh, look. So integral from 0 to a of square root of a squared minus x squared dx. Now I got it as pi by 4 a squared. So wait. Oh, cancel out. B pi. Okay, just move the a here and then a b pi all over 4. Now so we got that a over 4 is equal to a b pi over 4. So a will be a b pi. I meant area, not a. So capital A, or actually area will be a b pi. Well, that's it for the video.